Okay, so yesterday we talked about measurement and rulers and degree of precision and built-in error in a ruler. Today we're going to look at a little bit more of a precision measuring device in calipers. A caliper tool looks kind of like this. I don't know if I have a good picture here or not. I don't. But anyway, it's a tool that looks kind of like this. It's got a main scale here, and then it's got this upper jaw, this one here. Turn this on. This piece up here that's stationary, it's attached to that main scale, the beam of the caliper. Then we've got the lower jaw, which is mobile, that slides up and down the beam, and this dial here that rotates as you go up and down. And there's actually a little friction fit, depending on what you have. Sometimes if you have a cheap one, it's just a friction fit gear. If you have a more expensive one, there is actually a row of teeth or cogs going down the beam of the scale, the main scale, that there's a little gear that rotates on as it goes up and down. So anyway, let's talk about reading these things. Start up here. We start out reading a caliper. Now, we used to talk about vernier calipers. I'm not doing that anymore because outside of tool and die making and machining, which is like 2% of machinists even, you really don't need the precision of a vernier caliper. A vernier scale is just kind of a weird old scale that was used to make more accurate measurements. Now we've replaced the vernier scale with the dial here. That dial can give us that next degree of precision. So when we read these, the main beam tells us two things. The first thing is whole inches. Most calipers, I've seen them as small as 4 inches, but most calipers are either 6 or 8 inches. I've seen them up to 10 or 12 inches as well. Actually, I've seen them up to 30 some inches. But anyway, standard calipers are usually 6 or 8 inch. So the first thing we have to find is the whole inches. On this scale here, what number do you think is the whole inches? The 2. Very good. So there's 2 whole inches here. So the beginning of our measurement is 2 point whatever. Second thing we need is to get the tenths. Now obviously if the 2 is the whole inches, those other slightly smaller numbers are the tenths. Where do we read them at? Well, there should be an edge on this mobile jaw, the movable jaw. We read it at the edge of that jaw. Here, is it past the 5? Yes. So it's 2.5, 2 and 5 tenths. The third thing is the dial, which gives us the thousandths. Technically, it gives us both the hundredths, and the thousandths. I look at the dial. What number is the dial pointing at? 15. So 1 is the hundredths, 5 is the thousandths. 2.515 inches is what that's saying. So looking at this one, whole inches. 5 tenths, 0.6, dial, 21. 5.621 inches. This one, 3.6666. That one's for you, Brennan. This one, 4, is that past the 9? It's kind of hard to tell. How can we tell for sure? We go up here. Here's 0. If we've passed the 9, the needle would be somewhere over here, past 0. Right now, the needle is right here, which means it's not quite back to 0, which means it's not quite to the next division, not quite to the next tenth. So this is not quite to the 9 yet, so it's 4.8. And then this is 87, right? Everybody catch that? Okay. This one here, whole inches. 0, very good. Point. Is that to the 3 yet? Not quite, no. 0.2. 7.1. Good. You guys can read this one all by yourselves. What does it say? Very good. 4.443. This one. Good. 1.142 inches. This one reads the same way. It's just a little bit different style. The jaw, you don't read it at the edge of the jaw. There's actually an indicator here that you read it at. So this one would be how many whole inches? 0.563. This one. 0.8. And 4. This one. 1.046. Good. That's it, pretty much. This one? 600. We've got that down. Let's skip ahead a bit. This one's a little different. This one is used a lot in cabinet making. A little bit in automotive sometimes. This is measured, instead of to a 1,000th of an inch, it's measured to a 64th of an inch. So what you get off the main scale here is the whole inches. What you get off of this is your 64ths. So this is 1 whole inches, 1 whole inch. This here is 1/8. 1/8 is how many 64ths? 8 64ths. So that'd be 8, 9, 10. It's between 10 and 11. Which one's it closer to?
11.
Slightly to 11. So that's 1 and 11 64ths of an inch. I got to show them to you. So this one, whole inches? 0, yeah. 1/2 is going to be 32. 33, 34, 35, closer to 34 or 35. 34. So 34 64ths, which would be reduced to 17/32. You guys get the picture? Yeah, we're not going to do a lot of those because automotive just doesn't use a whole lot. This one we are going to do because metric is becoming more and more popular. Need to be able to do it. Again, here there are 2 things we need off the main scale, but really just 1. This right here, this 1 and the 2 stand for whole centimeters. So this is 1 centimeter and this is 2 centimeters. Each of these marks in between is a millimeter. But remember, in the metric system, we don't mix units. We don't say 1 centimeter and 3 millimeters. We don't do that. So when we read this here, when we read our main scale, that one's actually kind of a bad example. Let me skip ahead one. But here, we don't say that this is 2 centimeters plus 3 millimeters. We would just say 2 centimeters is 20 millimeters plus 3 more is 23. We would say that's 23 millimeters. Does that make sense? And then this gives us the 100th of a millimeter. This is 0.96, so 23.96 millimeters. So this one, 52.41 millimeters. Good. This one, point. You got her. Not bad. This one? I think you guys have it. So to review. First of all, is this millimeters or inches? Millimeters. So the reading is going to be 27.60 millimeters. Millimeters or inches? inches. It's going to read 1.8. It's not quite back to the 0 yet here. 96. Millimeters or inches? Inches. Reading will be 2.4. So 2.486 inches. Millimeters or inches? Millimeters? This will be what? How about 22? 37. There's a reason I've been switching back and forth the last few, because that is the biggest mistake people make. They know how to read it, but they make the mistake of thinking inches or millimeters, confusing them. This one. First of all, millimeters or inches? Millimeters, you got it. 8. 28.28, very good. This one? Inches. Perfect. I think you guys can do this. Yeah. This one. Millimeters and 0.50. Is it important to have the 0 there? Should I just say 46.5? From what we said yesterday, it's important to have the 0, right? Because we need to know, we need to specify. We did measure this to the nearest hundredth of a millimeter. It just happens to be closer to 50 hundredths. Remember the difference between the two measurements, if you review from yesterday. The difference between 46.5 and 46.50 is the implied error. This is implying that you only measured to 1/10 of a millimeter. The degree of precision is 0.1. The implied error, you divide that by 2, you get 0.05. So if you set it this way, you're implying that you could be plus or minus 0.05 of a millimeter. Here, your degree of precision is 0.01. The last place by there's the hundredths. You divide that by 2 to get your error. This implies that it's plus or minus 0.005. So it could be off by 0.005 of a millimeter. That's a big difference in your precision. It's this error analysis like this that kind of one of my biggest claims to fame. When I was in college, I worked as a work study lab assistant for a professor named Albert Irwin. Albert Irwin, they called it high energy physics at the time. It was basically nuclear physics, particle physics. It was a very, how do you want to put it? A world-renowned research physicist. At the time I started working for him, he had been nominated for the Nobel Prize once in the mid-'80s. Didn't win, but he'd been nominated, which is quite an honor. He had a reputation for being really hard on lab assistants. Most of his lab assistants did not last more than 5 or 6 months. And what I discovered was the problem was the lab assistants couldn't understand what he was trying to do, and they would start asking him questions, and he'd get frustrated, and he would fire him. Well, it didn't take me long to realize I didn't need to understand what he was doing. All I needed to understand was what he needed me to do. So I didn't ask any more questions than I had to, and we got along. I was his lab assistant for a little over 2 years, like 26 or 27 months. During that time, what he was doing research on, in fact, when I first started for him, he was doing research on silicone isotopes and the emission spectrum of silicone isotopes. And what the emission spectrum is, and I know we're getting off into physics world here instead of math world, what the emission spectrum is every atom has electron energy levels, and when an electron is in one energy level and falls down to a lower one, it emits a small little ray of light. The wavelength of that light depends on the energy difference between the energy levels. And every energy level has a different energy difference. So it's falling from the 3rd level to the 2nd, it will emit a different color light than if it's falling from the 4th to the 3rd. Make sense? Kind of different level of energy. He thought he had found a different little spike in the emission spectrum of silicone. And when I came on, I did the error analysis, which is basically what we're looking at the plus or minus, and then carrying that through your calculations. And what I discovered, rechecking over the error analysis, there was a mistake that had been made, and the error in his measurement was actually larger than the little spike he thought he had found. And it was a very tense moment telling him that, and he was very mad at me. But he redid the experiment and found out that there was no spike there, that it was an error in the equipment, an error in the measurement. So I kind of saved him from publishing a paper that would have been a huge embarrassment to him. He published a paper as a Nobel-nominated physicist. He published a paper that has a math error in it. That could be the end of your career. So he was pretty happy with me for that. So it's really kind of an important thing. So anyway, I'm going to hand out a packet. In the packet, I want you to find the reading of the calipers I'm going to give you.